Oh wow, my mic's muted. That's great. Is there ever going to be a time where I start the stream and I get everything right first time? I don't know. I should really do, what I should do is I should put together a checklist. I'm going to have to explain all that again for the video that I'm going to make out of this. So last night when I was incredibly tired, the mistake that I had made was that I accidentally put this little resistor here, which is on the serial, on the UART side, which connects to the Raspberry Pi. I accidentally put this resistor between the emitter and the ground, which is technically a pull down resistor. But what it meant is that basically all of my UART pins were all connected to 3.3 volts all the time. And then whenever one of these transistors turned on, it basically would ground all of them. So all of the UART ports would be kind of pulled to ground, which isn't exactly what I wanted, and by any stretch of the imagination. So this works much better like a pull-up resistor, which goes between the power supply and the digital output here. So that means that when this transistor is off, current is still going to flow through to the UART. We're still going to get a voltage at the UART, and then when this turns on and grounds, only this UART pin is going to be affected and have its, because any voltage out of here will be ground. Well, the UART pin will basically see ground. Electricity is not going to want to flow, you know. It's, yeah, anyway, that's the way it's going to work. So good. So basically what I had to do is put the circuit together on my breadboard, which I have done, and it looks horrendous. But what we have is the MIDI connector here. We have this is impossible to see, but maybe I can zoom in. Wow. Let me go. Alright, yeah, so what I need like a little laser pointer or something. That'd be good. That'd be real fancy. No. I don't. What I do have though is a Samsung Galaxy S Pen. So yeah, we've got the MIDI DIN connector, 5 pins. Pins number, I believe, 4. And 2 are connected up. So pin number 4 goes down here and it goes through a 220 ohm resistor. No, that's the other way around. That must be pin 5. Maybe I've got that wrong, you know. Maybe I should actually check that. I don't actually know if it matters on this side of the circuit though, because all it has to do is turn on the LED. So as long, yeah, all right. It's just a closed loop circuit, so it's fine. Right, so yeah, that goes through there, or down there. Oh no, that's actually, yeah, that's actually correct. I've done that right. So that purple goes into pin number 1 of the photo transistor, which goes through the photo transistor, turns it on if it's a high signal, comes out of that pin number 2 through the 220 ohm resistor, back up through this green wire all the way back to pin number 5, that side, which is the this side of the circuit here. So this is the beautiful thing about photo transistors or optocouplers or whatever the hell you want to call them. They're probably different things. I don't know the difference, to be honest. That this whole part of the circuit here, which in this case is going to be the MIDI instrument, the potentially very expensive MIDI instrument that I'm going to be plugging, or instruments that I'm going to be plugging into this, is completely electrically isolated from my shoddy electronics over this side, and all I had to do was provide it with a photo transistor and a resistor. Now this is standard MIDI spec electronics, so if I load my stuff up again here, we can see that standard MIDI electronics electronic reference, it looks exactly the same. Right, so we've got, I don't know why it's got resistors on each side there. I don't know if that's necessary. But it doesn't even have a resistor here. That's the funny thing, you see. But I'm putting a resistor there because I want to limit the current going into my photo transistor. So having a 220 ohm resistor is about 25 milliamps or so of current flowing through there, and this thing is maximum rated for 50, so that's fine. Yeah, and then the other side will look quite familiar. We've got the 5 volt. In my case, I'm on a Raspberry Pi, which means I need 3.3, and that's another part of the circuit, is I can step down the logic voltage from the 5 volt MIDI standard down to 3.3 volts for the Pi. Or make sure it's 3.3 volts for the Pi, whatever this side is. And so that will go 3v3 through a resistor to the output, and then it'll flow through the transistor to the ground. So that's what I got. 3v3, resistor, out to the output, flow the transistor to the ground. Beautiful. Okay. And that's one module. That's one input module. Oh, that was a mouthful. Now, this is going to be an input-output module. The whole idea of this is I'm going to make it flip-floppable. So basically, I can turn this with the switch of a GPIO logic pin. I can switch this circuit around to this. Output, which looks a lot easier. I just haven't quite figured out how I'm going to do it yet, so I guess I will. All right. So, where am I now? We are just working with the input so far. So what I've also got on my little setup going on here is I have this plugged into my MIDI DIN connector, which is a crappy, cheap USB MIDI device. And I also have all this hooked up to my trusty, cheap, crappy oscilloscope as well. Which, at the moment, is reading some spurious voltages for no reason, but that's fine. So what I can do is, using a piece of software on my machine called, pretty sure it's like MIDI, that would make sense, wouldn't it? MIDI bar, MIDI keyboard, MIDI piano? Yes, that's the one. I found this quite handy just for sending out random MIDI signals. So what I can do with this one is I can set to my USB MIDI, my cheap USB MIDI device, and then I can hopefully, with any luck. Oh, geez, I shouldn't have pushed that at all. So I don't know why I'm actually not hearing anything. That's something else weird. Yeah, my audio is working. So yeah, we are sending out MIDI signals. Now I need to make sure that this thing's actually working, so I can just... It is. Now the other thing I need to do is try and pick up a MIDI signal. Now part of the reason why this wouldn't be working is because I have not powered this circuit with anything yet. So we need to go to the Raspberry Pi and sort that out. Now I'm just going to get rid of the USB device I had plugged into it. Okay, so we've got a GPIO headers there. Now we want to get ourselves a reference to the Raspberry Pi pinout. Pinouts in UART, there we go. We're going to go 3v3 power is on the inside of the board closest to the edge there. So that's 3v3. That little pin up there. The other side is 5 volts. We don't want to mess with that because that's going to ruin our day completely. Okay, so on my breadboard, I know that this side is the 5 volt side. This side is the 3v3 side. So I did have a wire available. Already plugged into the power rail. Whoops, I just unplugged, but I can plug that back in again. Let's go to mobile view here so we can see a little bit clearer. Yeah, so we are going to plug this into 3.3 volts like that. Oh, now I have some weird waveform coming through on my oscilloscope already, which I will put on screen soon. Don't need this right now. That is a spurious connector. This yellow here, I'm not sure. I actually can't see. I've got to lean over this damn thing. Okay, so the yellow is the signal. The yellow is our signal, and the white is our ground. There is no magic to these colors whatsoever. So if I'm looking at, I just want to set this up for testing. So if I'm looking at like, if I want to test this on UART 0, UART 0 RX is pin 15. So that is the 1, 2, 3, 4, 5. That's the 5th pin down on the opposite side to the 3v3 power. So what I can do is take that signal wire and look at my Pi properly. And plug that in to the correct port. This one down opposite 3v3 supply. Now that did not reset the Raspberry Pi, which is usually a good sign that I haven't done something catastrophically wrong, which is good. And being a little blasé here. Alright, and now we need to also hook up the ground. So the ground, the reference is all going to be going through the Raspberry Pi, so that all needs... power is being supplied, 3v3 is being supplied from the Pi, so the ground reference should also be the Raspberry Pi. So we have that sorted. Now the ground we can see is on the 5 volt side, and it's the 3rd pin down. I could go on the 3v3 side, opposite. I actually quite like that, opposite the RX pin. So I'm going to do that, just completely opposite the yellow pin. Let's do that. They're all connected together anyway, so if you put a multimeter on them, that'll say 0 resistance. Okay, now I've done that, that was actually a good sign because my oscilloscope, my oscilloscope yes, some blooming room. Right, my oscilloscope is actually showing a solid average 3.3 volts. That's actually just about the most accurate I've ever seen this oscilloscope show a voltage. Wow, I'm impressed. Yeah, V mid 3.3, so it's wavering a little bit, but that's probably just the noise of this damn thing. So now what should happen is if I go back to full PC here and I now start playing some instruments. Oh, we can see some waveforms coming up on that oscilloscope. That's beautiful. And even the UART decoder down the bottom is saying some numbers. So that's very cool. So what I could do is I could also tap the original signal as well, which might actually be fun to do. Right, so I've turned off measurements. Now, if I put these two right over the top of each other, we'd be able to see the effect that the phototransistor has on the original signal very clearly. You know, don't mind me. There was absolutely no need for me to do that because I haven't hooked up the other side yet. So that's what I'm going to do. Now the other side, how's that going to work? I just need to measure across the pins. I just need to measure across the pins of the MIDI connector. So it shouldn't be too much of a drama. What I'm going to do with that, I'm just going to wire up something janky here. Just adding a couple of extra wires into my breadboard, just pulling off the MIDI pins. Now the question is, I don't know if I've got these around the right way. I mean, I think I do, actually. I think I do have them around the right way. So yeah, we've got... Oh, they're on different scales. Okay, so that's important too. I got my channel 2 on 2 volts. That's better. Okay, so 2 volts per div. So that's reading a very noisy 5 volts up there. Now, why is it very noisy? I have no idea. Probably the crappy USB, cheap USB device that it's running through. Excuse me. So something's happened, and I've lost my signal on channel 2 for some reason. Let's just check the obvious. I've got my 3 volts. So that, okay, interesting. That's only going up slightly. That's not going up to 3.3. Always a little concerning. What if I detach this? I don't know what I've done and when exactly that signal disappeared, but it's a little worrying. Now the thing is though, I should be able to see a MIDI signal coming through on channel 1, but currently I'm not having much luck seeing that. The MIDI thing is flashing, so I think I've done something really stupid. I think I have essentially wired something up totally in reverse. Oh, that'd be it. I grounded the, well, that was a bit dumb. I grounded the, so it does matter which way around it goes. Yes, who would have thought? Okay. I grounded the 5 volts by putting the ground of the oscilloscope there. So that was silly. Okay, that looks much better. Okay, that looks way better. Alright, so now we've got 5 volts up here and 3.3 volts there. So now if I drag around on here, there we go. We're getting some signals. So now we need to capture these signals. Now the way to capture these signals, we need to set up a trigger. So we're going to do that with the trigger section of the oscilloscope over here. Basically, it's low active, so I want to capture it when one of those signals goes below a certain point. I mean, if I just set the trigger to 2 volts, when it drops below 2 volts, it'll start capturing. Then I go into trigger menu, and I want to say edge type, our source channel. It's going to be channel 2. Channel 2 is the 3.3 volt, so that's fine. On the falling edge, so as the signal decreases. Auto, I don't know what that means. I don't know what the 50% means. Hold off 1 microsecond, sure. Now, from what I could see, just dragging my mouse over, it looked like my time period was okay, but I might want to zoom out a little bit more. So now I've dubbed, that's 200 microseconds across the whole window there, so I should be able to see the whole pulse pretty nicely. Right, so now I guess I can arm this. So we want to capture a single sequence, so I push the single sequence button. Right, and that's going to wait now for that trigger to be fired. So all I should have to do is click on a note. I say all I should have to do is click on a note. Actually, you know what? I need to move off the note, because that's Well, ain't my face red. Not working at all, is it? What have I done? Please adjust the trigger. No trigger. Oh, is it because I'm decoding? No. Oh, it's probably, maybe the UART's on. No, that's on channel 2 as well. Normal mode? I don't know what, I actually don't know what normal mode does. So maybe. Alright, let's go single sequence again. Okay, I've balled something up here. This is embarrassing. Well, it's not that embarrassing. But I've definitely ballsed something up. Falling edge. Right, let's see. Yeah, I'm getting bloody signals here. Okay, I think maybe what it is my time thing is not good. So maybe we should work this out a little bit. Maybe I'll go back to the computer for a second and we'll just get out our calculator here. Let's go. So we've got bits per second, right? We've got, if I want to see, if I want to see 8 bits of data, so we're going to go 31 to, this could be completely wrong, I'm kind of guessing here, divided by 8. Okay, so basically we can have 3,900 MIDI messages. I could probably look this up and actually corroborate this with old Googly here. Let's go. How many MIDI messages, midi-chlorians? How many MIDI messages per second? 1,000 average MIDI commands per second. Okay. Since each MIDI message requires approximately, 3,125 bytes per second, which is a little bit less than what I said because there's some peculiarities with the timing, the start things, and time between each, but it's pretty darn close. Oh, well, actually divided by 10 because, yeah, okay, that makes sense. So 1,000 average MIDI commands per second. A single MIDI event takes around 1 millisecond to be transferred. Okay. So what are we saying? Am I zooming out more? Am I going to 1 millisecond? No, that's too small. 500. Yeah. I'm going to go back to 100 because, I mean, that had the beauty. The 3 bytes. I don't know, I'm just going to play around with the timings on my scope here for a second. Alright. I swear this is going to work at some point. Come on, man. I had this working the other day. What is going on? Okay, well, let's go UART. Maybe this is going to work better. Yeah, that makes sense, right? Oh. Single sequence of UART, please. Bring it. Oh, come on, this is just being annoying now. Trigger is... Why is the trigger set at -4? I don't know what the heck is going on with that. It's weird. This thing here is saying -4 for some strange. Yeah, see, that worked. That captured something. Not what I want. Like it's forgetting the trigger setting. There we go. Okay, well that's not ideal because my Raspberry Pi side is not showing a single damn thing. Well, we can see our original MIDI signal anyway, the 5-volt one. And one thing after another. Maybe, you know what? I hope I didn't break it when I shorted that out before and did the wrong. Right, I'm worried that I did. Oh, it'll teach me. Yeah. Okay, so look at that. We're getting a beautiful picture of the changing MIDI signal as I scroll up and down the keyboard. That's very nice. But we're getting absolutely freaking nothing on the other side, which is not good. What we are getting though is a solid 3.3 volts. So I have a feeling I blew the photo transistor. I'm just going to quickly swap that out and see if that is the case. Stand by. Technical difficulty. Okay, it wasn't that. Well, that's kind of good, because that means I didn't balls up a photo transistor, which is nice. I've still got all. Pretty cheap. Something else. I know that it's measuring a signal because it's getting 3.3 volts, so I didn't completely destroy my oscilloscope. That's also something. It's not switching. Why not? Maybe I've got the maybe I've got this on the wrong side of the resistor. Maybe I need to have it. No, see, because that pulls it low as well. Okay, I know that that side works fine, because I can get a really clean signal. Not clean at all, it's so noisy. I don't know what's going on there. It's the other side that is not switching correctly. Like, I'm only measuring 3.3 volts, I'm not actually measuring... the signal, and it might be same mistake. I really don't think so. I could have blown a resistor. I mean, that's another possibility. Like, if I turn off that channel, I'm getting nothing. Horizontal position back to the middle again. Maybe I just screwed up the view. Oh, this is bizarre. What is going on? We've got DC coupling. Strange. Well, I know it's not the resistor because I've got 3 volts flowing through it. Okay. What have I done to my channel 2? What have I done? Isn't that strange? Oh, okay, I am getting a signal there. Like my oscilloscope's crashed. I'm going to restart it. If in doubt, turn it off and turn it on again. This is a new one though. I've never had that. I can do default setup though. That's another way. Well, that's another way of clearing out any bizarre settings that I might have put on it. Okay, so now channel 2 is working. And channel 1 is working. Okay, this is really strange. I have no idea what's going on here. There's something to do with the fact that maybe we're on different grounds. That maybe we're isolated and these two channels don't like that. So like if I tied the grounds together, we don't want a ground loop. This is the issue, right? We don't want to introduce a ground loop. So okay. How do I tie these two grounds together? I'll just do it the old-fashioned way with another wire. And now it's not working. Isn't it weird? Well. Anyway, look, let's capture a single sequence of this. And let's zoom in. It doesn't look bad. Like, you can see slightly, if I go up on here, you can see slightly rounded corners on the rising edge. And if I wanted to, I could measure that. Oops. It would just bring this down a bit. And what I could do is I could bring up the cursor here. And we can use the cursor to measure this stuff. So I can go... See, I mean, it's stuff all really, isn't it? If I put one cursor there, put the other cursor, like roughly where that signal stabilizes. Like even if I'm being pretty conservative, we've got a 20 microsecond rise time, which is fine. Like, I mean, to fully risen, like it's gonna trigger like back here, like 10 microseconds. So she's all good, mate. Whatever. Okay, that's enough farting around with the oscilloscope. That took way longer than I thought it was going to take, because the oscilloscope was being a pain. Alrighty. But at least we know we have got a 3.3 volt signal coming into the Raspberry Pi, which is good. It's a good thing. So now what we can do is I can set up my development environment for this. I'm gonna go new window, and what I need to find out is, can I start a VS Code remote server on the Raspberry Pi itself? So that would be handy if I could. Can I start a VS Code remote server on a Pi? Remote SSH extension within VS Code. Yeah, but the problem is, okay, so we're going to do that first. We're going to go terminal. Let's have a look at setting this up. This is going to be really handy, because that means I can program directly on the Raspberry Pi, and I can monitor everything from my PC, which is going to be really nice. So SSH is enabled, so I go SSH MidiPunk.local. Password is that. ls/dev, so we can see our serial ports there, TTY-AMA0, which is nice. Let's install interesting. So I don't actually need to install anything on the Pi. I can just connect directly via SSH. Who knew? Let's go open, connect to host, add new SSH host. We're going to go the mess at MidiPunk.local. Click SSH configuration folder update. Alright, we'll use that one. Host added. Connect. Initializing VS Code server. Select the platform of the remote host. It's Linux. Enter the password. Make sure that was obfuscated first. Downloading VS Code server. Connected to remote. Oh, this is sick. This is cool. Okay. And now what I also want to do is I want to save this as code workspace. So save workspace as home mess. No. What I'm going to do is go show local instead, and we are going to save this into our development drive. We're going to go dev, we're going to go workspaces, and we're going to call it MidiPunk. Code workspace. Beautiful. So this is awesome. I'm currently... What's... Okay. Well, it will be awesome when it works, because currently it's locked up and doesn't seem to be doing anything. Okay. Super ideal. Oh, jeez. Okay. Monkey's going on. Password again. Let's try this again. Reload window. Okay, let's try. If it lets us in this time. Yes, I trust the authors. I think it's because I saved the workspace as I was trying to do it. So we should be in the Raspberry Pi. This is great. So let's go terminal. Yes. ls/dev. Oh, we've got all our stuff there. We've got our serial ports. That's perfect. Got Copilot trying to edge its way in there. So I can... So what I might do is I might just go make to MidiPunk and we might start developing in here. We'll call this the mess/MidiPunk, and that's going to be our base folder. This project. Enter the password again. Why does it keep asking me for that? Is there a way I can... And now I don't know where my Explorer's gone either. I've got to set up the windows a bit here. Alt. Explorer. Okay. Cool. All right. This is good. So now I've got all of that stuff hooked up to the Raspberry Pi. I've got this beautiful digital signal, UART signal, MIDI signal coming in to the Raspberry Pi on serial 0. I wonder if there's a way that we can just monitor the serial output. I don't want my secondary control bar, so that's Control-Alt-B, isn't it? Yep, that's right. Shortcuts for the win. Know your tools, which half the time I don't. Okay. Back to old Google. We want to go... In fact, I'm pretty sure that I made some notes on this. I'm pretty sure that if I go back to my Obsidian notes, that I have notes on... Hey, TTY MIDI. So I'm assuming that TTY MIDI is not something that comes with Debian Linux Raspberry Pi version. So, gosh, I seem to remember, this vaguely rings a bell. I seem to remember using this a while ago. It allows external serial devices to interface with jack MIDI things. Okay, so let's have a look. The TTY MIDI source code is comprised of a single C file. To compile it, just run the following command, make. This program depends on jack. After you compile it, you may wish to copy it to user bin for easy access. Okay. Oh shit, you can connect to TTY USB as well. So maybe I can connect to USB devices? That's cool. Alright, so Basically, I want to... Go W get. Wait. That's not what I wanted to do. That's not a release. Okay, RM mod star. Oh. What? Oh. What? Oh, mod. Jeez, that was close. I almost deleted MidiPunk. Not there's anything in there yet. Okay, so we want to now go to oh god, I'm getting distracted. Okay. MIDIPunk, we are going to no releases. Right, so I probably just need to clone this, yeah? I probably just need to go get clone. Music's a bit sleepy, to be honest. I need something like lo-fi with a little bit more of a beat. Sleepy. Let's have a look. The Lo-Fi Cafe. That's much better. Okay. That's way better. Alright. Okay, so now we should have get, so we can go get clone that. Now we have DD space mod TTY MIDI. I love the tab thing. Oh. Without typing in a folder, you push tab and it completes. And now we just need to type in make. Cool, because we don't have Jack, which we don't have Jack. That is because we didn't follow these instructions. Two megabytes. We can spare 2 megabytes. Wow, that was really fast. Okay. Now, do we have... We do. We've got executable... .so. What are .so files again? They're like... some kind of plugin, basically, eh? So anyway, what we can do is go ./tty MIDI. Error opening Jack client, really? What if we go help? Okay, so let's go baud rate. Default is 31250. That's good. Okay. Device name of the jack client. Default is TTY MIDI. That's all good. Yeah, let's how about we just ban decaying biology, something or other. Spam. All right. Now TTY MIDI. So we don't need the baud rate. Serial device to use. So we want, for this one, we want -s. And we'll go /dev/TTY AMA0. We've still got this jack server thing, which I'm not exactly sure. First, yeah, to connect. What? So that this is strange. Am I missing a command? Interesting. I wonder if I need to like you need to kill the existing pulse audio process. It's almost like it hasn't installed. Well, let's exit the terminal and let's start up another one. And not working. She ain't working. That's not great. I wouldn't have written this note if it didn't work. I wonder if I can actually just delete this. So sudo apt uninstall what's it called again? Libjack. Is it libjack? Valid operation uninstall. Remove. Oh my gosh. What is going on? There we go. Yes. I don't remember building this last time I used it, so... RM... Should have gone RF. Okay, so now what about sudo apt install MIDI TTY? Oh, TTY MIDI. Oh, I should be so lucky. Shameless plug. I wrote this. Oh. Okay. This is familiar. This is what I wanted. Okay. Now, am I gonna have my face read? Because, no. I didn't. So, that's good. That's what we need. This is the one that I remember. So, what I would like... Get TTY MIDI. Okay. That is just the link. So we can just go copy link. And here we can go wget that. Tar usage. Creepers. Oh my gosh. What the heck? I'm not doing all of that. This is a absolutely massive help file. It is ridiculous. Okay, extract. So examples. Here we go. Create, archive, list all files, extract all files. XF. Let's see like what these options actually mean. I've never bothered to actually learn. X is extract, obviously, which makes sense. F must be like, is that force overwrite? No. Use archive file or device archive. Interesting. Right, okay. So basically you go XF archive tar, which okay. Tar minus X F. And how do you expand it to a folder? Local file, compression options, device blocking. Select output stream. Change to directory. recurse into directories default. It must just be option file. Yeah. Nice. So we do have to make this. Read me. Right, so I might have been looking at some random fork of it before. So, right, let's go sudo apt-get install. Unable to locate package. Why is it DE? That's German. I'm just going to go sudo apt install. No. DE? Oh, dev. Is it supposed to be dev? Yes. Yes, it is. Okay, now we should be able to go make. Oh, I made it anyway, even though there was a warning. Return type defaults to int. Sure. But it didn't stop us compiling, so that's okay. Now we go /tty MIDI. And of course there's no USB device. So what we can do, now we've built TTY MIDI, is specify the serial device that we want to connect to. And the one that we want to connect to is dev TTY AMA0. Permission denied. Fantastic. Sudo. Look at that. Nothing. But not for long. Because what we're going to do, very carefully, without a false trigger here, we're going to go piano. MIDI piano. Wait for it to init. We're going to change the input to USB. This is really exciting. I'm really excited for this. I have a feeling this is going to work. Oh, it does work. Unknown MIDI command. We got something coming through. It ain't MIDI though. I don't know what that is, but it's not MIDI, but it's some kind of message coming through the serial port, which is better than nothing, I tell you. Okay, so what I'm going to do is I'm going to remove any potential sources of noise and bad grounding, which we've got going on here. So basically I'm going to detach the oscilloscope. And all the spurious stuff which might be interrupting a beautiful clean signal. Okay, put these away for now. MIDI. Okay, it's coming through a lot more consistently. But it's not correct. That should be firing off program change events. Stuff. Okay, so we're not quite out of the dark yet. Whoa, unknown MIDI command doing some crazy stuff. Okay, what's our signal is... Something doesn't feel right. So we got a very, very obscenely noisy signal here. And that, okay, I don't know if I trust this, I don't know if I trust this jumper lead, actually, to be honest. It feels very, very, very loose. So I'm going to use a different one. Oh, what do I need? I need a... feet. So that's my signal. Oh, I might have had this around the wrong way. I might have actually had this around the wrong way. Which, you know, wouldn't completely surprise me. Let's go back to the drawing board, literally, and go to pinouts. Oh, excuse me, goodness. Right, so the ground side is on the 3v3 side, so hook that up again. Okay, we don't need the oscilloscope. Well, let's bring the camera back around to me farting around. And I guess I can... Okay, so this doodacky here. The yellow is on the resistor. So this is our signal. And our signal is supposed to be GPIO 15. Which is on the outside 5 up. 1, 2, 3, 4, 5. Alright, right, and next is the ground, which I know is above the 3v3 on that side, and the ground is going to be attached okay. Just make sure my USB device is still sending signals. Okay, let's close down that port and we're going to try again. Unknown MIDI commands. So that's not super ideal. We are seeing something coming through the serial port. What I have, you know, I know what the issue is. I know what the issue is. We're at the wrong baud rate. So we actually need to specify the baud rate as 38400. That's standard UART baud speed. By default, TTY MIDI uses 31250. You can't actually tell the Raspberry Pi to use that speed. It don't work. There's those device overlays that we put on, that UART MIDI device overlay thingy that we did. Okay, this should work. This is going to work. It's not going to work. Okay, fine. Whatever. Prove me wrong. Fine. I'm so excited about nothing. I swear that's it though. I swear. Maybe I just got the baud rate wrong. Just going off memory. Baud rate. Default is 115,200. Well, that's definitely wrong. So maybe I can use 31,250. Maybe this is going to work. Baud rate 31,250 is not supported. Yeah, of course. Okay, 38,400. I literally just did this. There's no point me doing that again. Let me think. No one come up. Let me think. Let's go to the boot firmware again and just double check our config file. So we're going to go cat config.txt. And we've got UART MIDI UART 0. Enable UART. Maybe I need to put on DT overlay UART 0 as well. I have not done that. I reckon that might be the case. Let's give it a go. Sudo config.txt. Sudo, excuse me, nano text. Go right down to the bottom. Go DT overlay equals UART 0. And I guess, yeah, we just, I wonder if I can. I can't do that, can I? I can? But now all my TTY AMAs are gone. Oh dear. Alright, well, we'll just do a reboot anyway. Oh, enter password. What do you mean could it connect? I just saw it suddenly connect then. Okay, this could be a bit of a pain actually, doing this. Doing any reboots through VS Code doesn't seem like a good way to do it. Yeah. I feel like just good old-fashioned terminal is going to be the way. TTY AMA 0 is back. Heck yeah. This is good. Okay, so we're going to go cat/boot/firmware/config.txt. And we've got our UART 0 overlay. So I reckon this might have been the issue. So I think now if I go to TTY MIDI and we go ./TTY MIDI and we go serial device TTY AMA 0. What? Oh. /dev/ unknown MIDI command. Fair enough. So now let's set the baud rate to 38,400. And we got nothing. Oh, that's so frustrating. I wonder if it works on another serial port. So let's check out a different serial port and see if it's a problem with serial port 0. So we'll go to port number 2, which is RX pin is 28. RX pin is 28. Okay. So RX pin 28, that's going to be 1, 2, 3, 4, 5, 6. The 7th down on the outside. Alright, we'll give that a crack. See what happens. This is going to be annoying if it works, because there's going to be a lot of debugging going on, or trying to figure out how to get it working on AMA 0. No, this was port 2, right? Yeah, I'm not really seeing anything better there. I'm seeing exactly the same issue there. What else can we try? Print idle. Name of the ALSA MIDI report board rate. Oh, actually, I wrote down the command in here, didn't I? /v dev. Interesting. Did I do 34,800 or 38,400? $38,400. That is the correct one. Okay. I don't know what /v does. Verbose. Produce verbose output. Oh. TDY AMA 2. What? It friggin' works. Why does it say unknown MIDI command then? What? Wow, that's very cool. Oh, pitch bend. Oh yeah. Oh, select. Oh. Woohoo! Heck yeah. Wow, that's fast. Okay, that's awesome. That's very cool. So, yeah, we're actually going through a USB MIDI device, 5 volts, through an optocoupler, which is opto transistor, which is, as it turns on, it is pulling the 3.3 volt signal down to ground. Yeah. Otherwise, the signal is high, and our Raspberry Pi is reading that through the serial port. So that means I can probably go back. We need to make sure this is working, so I need to go TTY AMA 0. I need to go back there. Hook that up again. Mission denied. I don't know why. And it works. Yeah. Okay, so we got serial port. Okay, I'm going to go through and test all of them just for absolute safety, so I don't get in a position where I'm trying to code something and it's like I actually don't have the data available. So what we are going to do here is go to pinouts and UART. So we've tested 0, that works. We've tested 2, that works. Let's test number 3. The RX pin is 29. Raspberry Pi pin header 29. is going to be 1, 2, 3, 4, 5, 6th in on the board side. Sixth in on the board side, and back into the terminal here, and this is TTY AMA 3. She works. Bloody beautiful, mate. I wonder if my sound effects are working yet. Oh, yep, they are. Oh, hell, I pushed the wrong button. Oh, okay. Love it. I keep hitting the wrong buttons. Shit. I hate this stupid shit. Anyway. There we go. That's the one I wanted. Yeah, we win. We win this round. So TTY AMA 3 is good. We're not using 4, and we want to check out 5 as well. So let's run that, and we are going to have a look at the pinout for number 5, which is 33. That one should be reasonably easy to find. It's the 4th. The 4th up. That one there. So, oh, there we go. It works. Wrong button again. Okay, anyway, thank you. I was going to be watching this crap, so I don't have to worry about embarrassing myself. Okay, let's continue on. This is a really good, this is great. We have cracked a big part of this. We have cracked the electronics section, the input, MIDI input via MIDI DIN. Now, actually, what I want to find out is I think I can monitor USB MIDI devices as well. So, what I'm going to do is something a little bit crazy, wild, it's not. Okay, so I've got my little JT 4000 micro synth. I'm going to plug that into a USB port on my Raspberry Pi. I don't know, whoa, that's not the crazy bit, okay? Oh, you didn't even see what I was doing there. Okay, so basically I've plugged this JT 4000 mini synth into my Raspberry Pi. Now, as I said, that's not the crazy part. The crazy part is that we're going to go back to the thing here, and we're going to go ls/dev, and I'm going to see like sound. So we got, oh look, we've got a little MIDI device under our sound thing. I wonder what that could be. But you know, we've also got this by ID thing, so I wonder if I, which might be nice, or by path? What's by path? I don't know. That's, okay, so that's by Broadcom 2835 audio device and some PCI Express, PCI USB. So that's the USB device as well. Okay, so that, I think that is our little synth, but that's a really crappy name to deal with, so I'm not going to deal with that. We're going to go by ID, and we got USB Behringer JT 4000 micro 2082 38705 431-00. way better. In fact, actually, I think MIDI C1D0 is quite good. So C1D0, what does that mean? C1, connect to one device 0, maybe. So I wonder if I do this. The only thing about using by ID, and I think I'm going to do this in the software, is look at the name of it, because we do kind of want the vendor ID, like the name of this device, because we want to kind of save. We want to save what the device is in the system. So if people plug it into a different USB port, it's not going to affect operation. So we're going to unplug that. Plug that into the bottom. So looking here, it's C1D0, and now I've put it in a different port, one layer down, which I have a feeling it's going to be C2. I don't know. No, it's exactly the same. Okay. Waste of time, wasn't it? Dev/sound/MIDI C1D0. It can't be this easy. Even though it might be. Okay, let's get rid of the baud rate, because it's USB we're talking about here. Oh, it didn't crash. Oh yeah, it does work. Okay, so all we have to do is open up that USB device as a MIDI device, and it bloody works. Incredible. Technology, eh? We have the power. So, summing up right now, what have I got? I have got a USB MIDI DIN converter, cheap, crappy thing, plugged into my computer. I can play notes on this virtual keyboard. Goes through that USB device. Goes into here, into a MIDI DIN plug at 5 volts. And it goes through an optocoupler to isolate our MIDI device from our Raspberry Pi electronically. This photo transistor has 3 volts flowing through it. Or it did have 3 volts flowing through it. Probably doesn't now because I've pulled the ground off. And that goes into the GPIO pins on our Raspberry Pi serial ports. Beautiful. Absolutely astounding. So now I need to learn Go. Learning. Okay, I gotta update my stream stuff. Learning GoLang, MIDI, frame buffers, etc. Come chat. Exclamation mark. I also want to update my YouTube streams title. Okay. All right. I'm going to go get some food. I think. Actually, you know what I need to do? I need a BRB screen. So I'm just going to do something really lame for now. And I'm going to go add a source, and we're going to go text GDI. And we're going to go text verb. Not very readable, is it? I could just do this. Oh, that's blonk. What's a good text color that's readable? Probably none, because it's not about the color so much. It's more about contrast, and there is no way that I can get a lot of contrast out of all these colors on my screen, right? So let's just go with white. Select font, and let's go Arial black. There we go. Verb. Okay. Uh, I did have this stream transcoding thing going at some point. Not transcoding. Bloody captions. I have absolutely no idea. I want to start recording. Does it make any difference? Wonder. Oh no, my camera is about to die. I have absolutely no idea where the captions actually save to. So who knows? Stream recordings. Maybe I need to look at the plugin. Are the best. Right. Get cozy, comfy, and back into it. For just a little bit long. Alright, I need to power this camera. Well, I can do that. I mean, I could power it off the Raspberry Pi, couldn't I? Might not be the best idea. Because I want that synth plugged in. Alright, so let's go to I really need a power supply for this camera. I do have a battery, maybe I can just... Working remote tomorrow, so... Duolingo. Alrighty, let's move along here. Turn my monitor up a little bit. There we go. All right. So we've successfully got this MIDI. This music sounds a bit loud, doesn't it? What if I turn that up a bit more? Just turn that down a smidge. There we go. I don't know, maybe, is that still too loud? Who are you talking to? I don't know. Alright. GoLang. GoLang. I need GoLang. Go.dev. What I want to do, I'm going to go in dev. Get started. Install the latest version. View the install documentation. Don't mind if I do. Okay. Probably don't need the little mobile instance. Ring. Fried noodles. I really felt like a Sprite. I have to go get one of those soon. Anyway, Alright, so to install this, remove any previous Go installation by deleting the user local Go folder. Okay, ls/user/local. We don't have Go in there. It's fine. Creating a fresh Go tree in user local Go. So rm/rf and tar. So we got to download that first. So let's we don't want the source code. We just want the download. Or ARM64. I think that's what we want, right? ARM64. The way to there's a way to see. It's like a there's a command Linux from the Raspberry Pi. Yeah, it's ARM. Do that. Not ARM v6, is that v8? Right. So we're just going to copy the link here, and we're going to go. We're just going to go wget that. Oh, gee. Right, after we've got that, we're going to... So I'm interested what... See, these are the commands that I usually just copy and paste without really looking into what they actually mean. So now's the time to learn. So R/C, so capital C is change to directory dir. Okay, so we're going to go user local, and then we're going to go XZF. So we're going to go extract. I don't know what Z is. Z is... F is the file name, so go1 blah. Z is gzip. Filter the archive through gzip. Okay, yeah, so tar... Right. Gotcha. So tar.gz files, we need to go exit it. So we gotta get the right file name in there first. Gonna help. Linux ARM64. Out. Sudo tar. Okay, do not untar the archive into an existing Go tree. Alright, we can add user local go bin to the path environment variable. You can do this by adding your home profile or etc profile for a system-wide installation. No, this user's fine. So we are going to go copy that, and we're going to go so, okay, this is another thing. Quickly clearing a line in Linux. How do you clear the line in Linux? Terminal. Control L. Control C. Interesting. Oh yeah. Yeah, it just escapes out of there. That's cool. Alright, so we're gonna go nano.profile. Nah. -rc.profile. Okay. Nano dot profile. This file is not read by bash. if bash profile or bash login exit. Okay. So include bash rc if it exists. Buffer is empty. Oh. Huh? What's all that about? Export path. Okay. Good. Cool. All right, so we'll write that out and we'll go Control X and we'll go source.profile. And we'll go version. Go installed, baby. A good start. That was so difficult. Alrighty. Getting started tutorial. All releases. Didn't mean to close that tab. No. Releases. Cool. Prerequisites. We're good. Install Go. So I think now is the time that we switch. Now is the time that we switch over to VS Code. One day this will work. Come on, man. Oh, good. It's working. Okay, fantastic. Here we go, MidiPunk. So this needs to be a Git repository. So I need to get into the mess GitHub. Sign in. No. I'm pretty sure that... Yeah, I've got my own. Beautiful. I do have my own, but is this what I actually want? So if I go to another user, let's add another account. I love site selling. Great. Passkey. All right. Let's have a look at my repositories. Vision in... I probably need to keep this a little bit more private than the mess. I want to see all of my repos. This is going to become... So the mess is open source software. So this is where I need to distinguish the two. This is tricky. So I'm going to switch over to the mess. And we're going to create a new one. We're going to call it MidiPunk. MIDI. Cool. MIDI, MIDI. What are we going to call it? MIDI router hardware. Raspberry Pi powered MIDI router. Raspberry Pi powered MIDI router. Open source Raspberry Pi powered MIDI router. Open source Raspberry Pi powered touch screen MIDI router. Nah, touch screen, who cares? Compact open source Raspberry Pi powered MIDI. That sounds good, right? Let's add a README. Add a get ignore template. What about Go? Choose a license. Licensing a repo. Choose a license. I need to work in a community. You're contributing to or depending on. Or we've got, I want it simple and permissive. Like making and distributing closed source versions. I don't want that. I don't want closed source on this. I want the open to be open. The new GPL v3 also lets people do almost anything they want except distributing closed source versions. So source code must be made available when the licensed material is distributed. Modifications must be released under the same license. Changes made must be documented. Create a text file typically named copying. Why copying? Strange. All the stuff I do need to think about going forward is this. I mean, that does seem pretty good. What if none of these work for me? My project isn't software. I want more choices. Unlicensed. It's incredibly open. Interesting. This feels like, this kind of feels like what I want. So I mean, this might be up for selection anyway. New Afro General Public License V3. What's Apache license 2? That was that community one that was. Maybe distributed without source code. Yeah, right. Yeah, okay. Apache license too. Be a learning curve if I get the wrong ones, but you know what? Whatever. Yeah, right. So we are gonna go into here, and we have to clone this into this current folder. So we're gonna go git clone that. Nice. All right. So we have a nice clean git repo here. We're going to go now we're in MidiPunk workspace here, so let's have a look at some extensions. We are going to what have we got installed? We've got Copilot chat, which we're probably actually not signed into. Or are we? To my secondary sidebar there. 3.5 son. Huh? Am I seriously signed in? I must be. through this profile. Local installed. Okay, so there's a lot of stuff that I don't need. Oh my gosh. Right, so we don't need div containers. We don't need Arduino snippets. We don't need draw IO integration is always fun. We're gonna keep that. We don't need that. We don't need that. I need to raise my desk a little. It up more. Naturally, you start to slouch up. JavaScript. No, thank you. Oops. JSON. Not as yet. Oh, JSON lines. Doing lines, baby. Edge tools. No. Myself enough coding and go. Remote SSH. Yes. SSH editing configuring. What does that even mean? Edit SSH configure. Yeah, okay, that's probably what we want. Tunnel. We're not in a tunnel, so we can disable that for the workspace. Remote development. Did you open any folder in a container on a remote machine? Oh, no. No, I need that. Connect to a remote explorer, view remote machines for SSH and tunnels. Yeah, we need that. VS Code speech. That. All of this is good. Recommended. Get out of here. All right, we're going to reload the window. Are we going to have to reconnect? Probably. Cool. All right. GoLang. Rich Go language support for VS Code. 15 million. I'm hardly a unique individual, am I? That's crazy. 15 million people. That's a lot. That's a lot of people coding in Go. You know? There's a lot of people coding in Go. And I guarantee you, 14 million of those are better coders than I am. GoLang tools. Alright, I'm just gonna stick with old the official GoLang business at the moment. Now we're gonna go back into documentation about GoLang and how to get started here. So let's get started with Go. Install Go. I've done that already. Write some code. Exactly what I want to do. CD home directory. Go mod init. Enable dependency tracking. When your code imports packages contained in other modules, you manage those dependencies through your code's own module. That module is defined by a go.mod file. It tracks the modules that provide those packages. That go mod file stays with your code. Okay. So this is like dependency management and any other thing. It's like package JSON or composer.yaml or something like other frameworks. cool. To enable dependency tracking by run the go mod init command, giving it the name of the module your code will be in. The name is the module's module path. What? Okay, well, I guess we just got to try that and then I'll see how it comes out in the wash. For more about naming, so in actual development, module path will typically be the repo location where your source code will be kept. Yeah, right. So, for example, the module path might be github.com/mymodule. If you plan to publish your module for others to use, the module path must be a location from which GoTools download your module. More about naming it with a module path. See that? Yeah, all right. In your text to create hello go. All right. So declare a main package. A package is a way to group functions, and it's made up of all the files in the same directory. Import the popular FMT package, which contains functions for formatting text, including printing to the console. This package is one of the standard library packages. We definitely need to know more about standard libraries. Implement a main function to print a message to the console. This main function executes by default when you run the main package. All right. So let's figure out this go mod thing. Read about this. Managing dependencies. Naming a module. When you run go mod in it, you specify a module path that serves as the module's name. The module path becomes the import path prefix for packages in the model. Be sure to specify a model path that won't conflict with the module path of other modules. At minimum, module path need only indicate something about its origin, such as the company or author or owner name, but the path might also be more descriptive about what it does. So the module path is typically of the following form: prefix. I need to be taking notes. Did I start a GoLang folder already? I did. Or I started a GoLang folder. Maybe. All right. Let's continue. We are going to Go guarantees that the following strings won't be used in package names. Test. You can use test as a module path prefix for a module whose code is designed to locally test functions in another module. Use the test path prefix for models that are created as part of a test. For example, your test itself might run go mod init test. What? Recursion. Okay. All right. The module path is typically of the following form: prefix / descriptive text. Prefix is typically a string that partially describes the module, such as a string that describes its origin. This might be the location of the repository where Go tools can find the module source code, required if you're publishing a model. Use this best practice if you think you might publish the model file. Well, I think I will be, so yeah. A name you control. If you're not using a repo name, be sure to choose a prefix that you're confident won't be a good choice as your company's name. Avoid common terms such as widgets, utilities, app. Yeah, okay. Forget. Yeah, conflict. Stepping on others' toes. For the descriptive text, a good choice would be a project name. What? But it says the prefix might include the project name. So why would the descriptive text be the project? Remember that package names carry most of the weight of describing functionality. The module path creates a namespace for those package. Okay, well, maybe that's in the case that I am using a repo. It's already got that name in there, and it kind of does. I guess the prefix is like github.com. And then oh, that's like the mess / MidiPunk. You like that? So let's have a look. Git mod init. Go mod init. It's getting to that time of night, is it? Creating a new Go mod module, github.com, the mess MidiPunk. At go.mod. Module. Okay. Alright, so that like yeah. Go clep. Go auth, go mod, go path, go proxy. Module proxy protocol, import paths, modules. Module auth, packages, package lists and patterns. I don't know what any of that means yet. We're gonna find out. Well, I kind of do, but like, let's be you know, let's be good. So we're gonna go main. We're on the main branch. So we're gonna go git commit /m -m. Now, I know I can do it over here, but I'm trying to get better at the command line because it's actually really handy to know how to use the command line as well. So I'm trying to do this. Git commit m init go module. Please tell me who you are. Yeah, okay. Git config. Git config user email is going to be nz.themess@gmail.com. User name is going to be my name. Git add everything. Git add everything. Git commit go. And then we can do git push. The extension GitHub wants to sign in using GitHub. I'll allow it. Sign into another account. We are going to go use a different account. We're going to go NZ the mess. Boom. Beautiful. Okay. Git status. Branch is up to date. Of course it is. So now we're going to go git checkout /b. So we create a new branch and we're going to call this what are we going to call this? MIDI input. There's no upstream branch. Git push set upstream origin MIDI and cool. Okay. So back in our help, we have got create a file hello go. So I mean, what's like, is there a is there a standard thing for this? Like, I don't know. Call it we'll just call it MidiPunk .go. Yeah. Go toolchain auto, installing two tools, go plus and static check. What's go plus? Nothing apparently. Okay, now we are going to I really need a better way screen. Maybe we can get rid of that. Maybe smaller. I think that. Now we're going to go package main. We're going to go import format, and we're going to go bunk main, and we're going to go format dot print hello world. Thank you. No semicolons. Naughty. This is a MIDIPunk project. And then we're going to go run by pushing F5, and let's see what happens. So far, nothing. All right, that's cool. Run your code to see the greeting. Node.js, are you serious? Add config MIDIPunk. I mean, surely you would think that Go has a debugger built into VS Code. The Go extension lets you debug Go code by utilizing the Delve debugger. Read debug Go programs in VS Code for setup steps, supported features. You can expect variables. Yeah, okay. I need more water. Like a fish. Activating extensions. What extensions though? No inline suggestions. The Delve command is not available. Run go install. Oh. MidiPunk.go launch.json VS Code. I mean, we could add this to git ignore, right? Right, now that's not going to come up in there. So add that and we'll go add VS Code folder. Ignore. MidiPunk.go. All tools, you are ready to go. Oh, that's cute, isn't it? Hey. Cute. Alright, well. Now let's see if we can run and debug. Starting DAP server listening 12700138755. Hello world, this is a MidiPunk project. Process has exited. Beautiful. Okay, so we're happy to announce that new DLV DAP mode of Delve integration is local debugging by default. Remote debugging, it is the default in pre-release versions. It is available with stable builds on demand with debug adapt to Delve DAP. Actually, and you don't get it. So open a file to debug and select the run debug button. Alternatively, you can start it doing that. If you already have launch configurations, run view will display the configuration list to choose from. The extension will choose a default configuration based on the file open in the editor. When you start debugging for the first time, or if the Delve executable on your system is too old, the Go extension may ask you to install or update it. Yeah, it did. To learn more about debugging in Go, review the features, and that's it. It didn't tell me really. Okay. Switch to legacy debug adapter. No, I don't really want to do that. Oh, for remote debugging. Perhaps this is actually what I need. Unless it did say up here pre-release versions. Pre-release. So if I go into extensions and I go to Go, this extension has a pre-release version available. Yes, please. I would like to do that. I would like to do the thing. Because if I can get native debugging in here, let's reload the window, opening remote. It's going to ask me for the password again. I'm not like overly concerned about that. It's not... Okay. Let's see if this does anything different. Oh, I saw the stuff come up. Okay, good. Yeah. All right. No, we're happy. That's cool. I saw it come up there, so we're all good. Gravy. Paste the following. Wow, fantastic. Standard library. This, I really don't like. Manage containers. Remove, 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 remove. Select a container for each new tab. Oh, I like that. Kind of forces you to be organized. We'll just call it we'll call it GoLang. Add new container, we'll call it general. Call it white. I mean, what? General, done. Settings. Open previous windows and tabs. Yeah, sure. Scroll tab. Cycles through tabs in recently used order. Open links and tabs. Of new windows. Ask for closing. Go tab preview. I've never been much of a vertical tabs person. I mean, it uses up so much space. Crazy. Don't show the sidebar. Dark mode. What's this blank square in the corner for? It's kind of just wasting space. Weird, eh? Oh, you can do tab groups in Firefox. What? I didn't know you could do that. Okay. Fine. I should have known. Should have known. Add tab to group. I swear that wasn't there last time. I don't. Anyway. What do we got here? Managing dependencies. I've got that open like twice. There's just not enough room up here. I want more room. Only show on new tab. Don't show. Customize toolbar. What is, I don't even know what that is. So that's a new tab. That is list all tabs. And then there's this random blank corner with nothing in it. Oh, maybe I should just... Being very mean to poor Firefox, aren't I? Very complainy. I don't understand. I don't fully understand. Oh, Firefox. New browser. I mean, weird because I test software in it, but like... Anywho. Install the latest version. Yeah, we're done. That's good. Cool code. What's this? Get started. Write some code. Cool code in an external package. Here we go. So this is really what I want to know. So let's start up. Now I was going to check my Obsidian on my phone because I swear that I started a GoLang folder. But yeah, it could be wrong. Could be wrong. Oh, you know, might be in the learning section. Actually, which I don't... It's kind of annoying that I don't have it here. Maybe I need to add... I've got GoLang general notes. Go run go mod init github.com/the mess. Just remember which way around this goes because it's square peg in a round hole. That's, I think it is. So we'll just call that package.go.dev. Yeah. Oh. Actually got it around the wrong way. I mean, okay. What I meant by that was I remember which way around the brackets go, not what goes in the brackets. So square peg and round hole. There we go. Okay. Package.go.dev. Good. Packages are published in modules. In your Go code, import the rsc.io/quote package. Okay. So, I mean, that's really quite simple, isn't it? So all we need to do is Go will add this quote module as a requirement, as well as go.sum file for use in authenticating the module. Authenticating modules. Go modules reference. What? Authenticating. Right, okay. The Go mod files, Go command. Alright. Go mod tidy. Cool. All right then. What I'm actually going to do, I'm going to add this. I should add some of these folders to here. Reckon. Wanted accessories. 2 times zoom lens. Oh yeah, and the anamorphic lens. Would like that. All right. Okay, well, let's go explore then. Let's go explore Go modules. What am I doing? KiCad. How-tos. Ooh. 5 ways to run a program your Raspberry Pi setup. Basically, system D themes like robust, service-based approach. Yeah, it does. MidiPunk. So, making and coding. I better put a folder in here. Cool. Udemy courses and self-learning. I mean, these can be living things, right? So I could always remove the... Yeah. All right. Go Audio is a MIDI format parser that parses the content of a MIDI stream and asynchronously send the data provided to a provided channel or collect the data into an accessible struct. Listen to incoming MIDI messages. Package that helps with the reading and writing of MIDI messages. Okay. Have a look at this. GitLab Go MIDI V. Don't you rub your face on them. All right. Sending and retrieving of MIDI data is done via drivers. The drivers take care of converting a running status into a full status. Most of the time, a single driver is sufficient. Therefore, it is handy that the drivers auto-register themselves. This also makes it easy to exchange a driver if needed. Different cross-platform implementations of the driver interface can be found in the driver's subdirectory. The SMF sub-package helps with writing to and reading from simple MIDI files. The tools provides command line tools and libraries based on. Alrighty. Let's add it. Import, could not import, no required module provides package. So if I remember correctly, the way to solve this problem is to go mod tidy. And then it didn't do anything. Oh, about that. Okay. Already, yes, I'm getting a little confused here with how to import packages. Managing dependencies, enabling dependency tracking, naming a model, adding a dependency. Here we go. Go get. Well, what the hell was this go tidy about? Oh, go mod. Yeah, that's what I did. Right. Okay. So that's what I should be just doing. I shouldn't be adding it like willy-nilly like that. I should be going go get GitLab. Go get it, go. Go get GitLab. Yeah. We got it. We got GitLab. We got the GitLab Go MIDI. Go. Import. Go MIDI. Is that like a thing? Like, or do I have to put in the whole thing? Import. Now, why is it squiggly? Imported as MIDI and not used. As MIDI? Can we do that? No? Well, how do I know? Like, can... MIDI? Dot import returns the MIDI import for the given port number. Get imports. Find import. Get imports returns the MIDI input ports. What? Imports. Ports. No. Declared and not used. Well, that's going to change soon, isn't it? Damn, we're going to run this thing. Available, no driver registered. Okay, so we need to register a driver somehow. And now what I'm thinking is that it's going to be something like, TTY MIDI or okay. Right, let's get back into our Go notes here. We'll tidy up dependencies. Go get module name. We'll add depend. V000, or we can do the whole latest thing. Covering available updates. So module updates, we can out like this. Why does it insist on doing code blocks? Okay. Code doc. Synchronizing dependencies. All right. That's all I need. So we are going to add this to here. Oh, actually, what I'm going to do, leave that out of, that's me learning stuff. GoLang ref, and this is going to be add tab to group, and this is going to be called GoLang hack. MIDI. So we channel key velocity. Do I need to learn about these drivers? Like, what the hell are these drivers about? Oh, G flat. Okay, so these are notes. Interesting. Variables. Listen to. Import. Receive function. Output. Imports. Message. Okay. So maybe if we go um in by name, in by number. Port number. Opens the MIDI import with a given number. In by name. The first MIDI import that contains the given name. Find import. I feel like I need some I feel like I definitely need some more guidance on this of like how to actually open the ports. In by name, my MIDI keyboard. Here we take the first port for first import. For real, consider in by name. So the thing I don't know at the moment is how to set up the drivers. The default driver. So do I not have like a default driver? Is that? GoLang syntax is still a little bit okay, so chat is like frickin' GPT is not good at Go at the moment. I don't know how it's any different to what I just did before. Oh, whatever. Print in. So then we go, so, I mean, this is probably going to fail, right? Like if I do this. Declared not used. Okay. So, println import in. I mean, nil. Find import. Get imports. Import. I feel there's a port like name or something like that. Pretty bizarre. Man. I'm getting too tired for this. I need to go to bed. I'm on that time where I should just stop. Got Go installed. I've got it set up nicely. I should approach this with a fresh brain. with a fresh Brian the next day. If anyone's watching this video and somehow got to this point in the video, please feel free to subscribe. If you're on YouTube, follow on Twitch. I'm going to be making this damn thing, and this is only the beginning. I've got huge plans for what I want to do with the mess, vision, company. I want to build. I got a lot going on that I want to do. So be a part of it. Get in early days. Sitting here talking by myself. It's good to have it documented so I can always remember where it began. And out of mess will come magic. Believe me. Believe. I'm like a friggin' politician. But believe me. It'll happen. Alright. The drivers auto register themselves. That's in the drivers subdirectory. They register themselves, do they? See, that isn't. Because I'm pretty sure that the driver did not register itself. So let's go go run dot. Can't get MIDI imports. No driver registered. Okay, let's do a googly search on this. Find it. Way. So go MIDI. RT MIDI driver. So do I need to So maybe what it is that I actually need to look at the I need to look at the repo in order to Oh, what is with GitLab? Sign up with GitHub, thank you very much. Or Google. I'll do Google so then I can keep that separate. Separate. Oh, yeah, I really gotta go to sleep. Please confirm your email address. Don't mind if I do. Burma. Oh, you shouldn't. Alright, verification successful. Let's go to this. Oh my gosh. I'm signing up because I want to a different reason. Why are you signing up? Browse. It's code repo. What would you like to do? Join a project. Just me. Right, it's gonna let me in this time? Page not found. Excuse me? But it literally downloaded. Oh, this sucks. Why? Why is it saying 404 not found? What about that? There we go. Crikey dick. Crikey. Drivers. Read me. All drivers must obey the following rules. The problem is I don't fully understand why I would want examples. Complete MIDI standard. Wow, that's impressive. For cable communication, you need a driver to connect with the MIDI system. Currently, the following driver. Right. What's this underscore thing about? I don't get that. Defer. MIDI. MIDI. Close driver. Yeah. Okay. Okay. I don't know what the underscore does. Auto registers driver. So the underscore is right. So if I could just like call that MIDI, yeah? Ah, so that's the as functionality. Okay, I get it. I get it. That. So now I should be able to run. Get imports. That's good. Although, I mean, that is only we've got a MIDI through port here. So port MIDI. So I don't know if there's a way I can make, like, say if I went LS, no, down here. I'm not even plugged into anything at the moment. So five, and then we go C space TDY MIDI. Go sudo dot slash TTY MIDI. We go S and we go slash dev slash TTY AMA 0. I have no idea. Correct. And we go verbose. I have no idea what port I'm into or anything at the moment. Like the software has crashed on me. Oh, there it goes. So AMA 0 is 14. 15. Port 15. Back to here and go pinouts on the Raspberry Pi. Oh, it is time for bed. 15, which is pin 10, which is opposite the 3v3. And it is 1, 2, 3, 4, 5 up, which is exactly where I've got it. It's not where I've got it. I think I just may have balls did something up. 1, 2, 3, 4. And that's the ground. So the ground is going to go opposite. Oh, there we go. Nice. So do I need to put in a baud rate? Again, I can't remember. /B 38400. I do. Look at that. Okay, so let's create a new terminal. And let's go run dot. TTY MIDI. What? No shit. Okay. I mean, the thing is I could raw listen to the serial port. And I could pipe that in. I don't know, but I'm going to call that a great success. So I'm going to say we've got installed Go MIDI port list, including via TTY MIDI. I mean, this is probably going to be the easiest way for me to do this. So I don't have to bother about serial communication and all that sort of stuff. I just need to spawn a process, spawn the TTY MIDI process to listen to the serial port, and then I can attach. I mean, maybe I need to play around with some of the other drivers as well and have a look and see. Can't find import. It makes me wonder, like, what is TTY MIDI like able? What other stuff can it do? Connect serial port devices to ALSA MIDI programs. I mean, that's exactly what this is for, right? So what about like Go MIDI serial? Over the wire MIDI data. Because, yeah, I mean, what would be pretty cool is to be able to open up the serial ports and monitor them in Go. Seamless integration with IO Reader and IO Writer. That makes me wonder if, like, oh, it just seems too good, like, to have TTY MIDI doing the hard yards for us. Go spawn process. Command helper creates an object to represent this external process. The output method runs the command, waits for it to finish, and clicks its standard output. If there were no errors. Yeah, right. Print values read from serial. Oh, that'll be interesting. Only printing signal to the screen and nothing else. Oh, yeah. Oh, see, look at that. I mean, that doesn't make a lot of sense, does it? Oh, what? I don't know what's happened there. It's like it gets stuck. Kind of strange. That should be outputting program change message. Anyway, I'm just farting around. Stage changes and still go MIDI, blah blah blah. Okay, good night. It's time I went to bed. Thanks for watching. Yeah, don't forget to, you know, come join me live, because I talk to myself and I much prefer having people to actually talk to in chat. I miss my old gaming stream, but I'm sure this will grow with time. So subscribe if you're on YouTube, follow if you're on Twitch. Come say hey, come talk about tech or something interesting, and stop me from just talking to myself the entire time. That would be lovely. That will mean I'm not insane. Well, I don't know if that's what it will mean, but it'll help me feel better anyway. So, yeah, all right. Okay, take care.